Hello friends, welcome to this second lecture of your module 2. So in the previous class, we have started with your discussion of the RISC and CISC architecture. To give you a small recap of the previous class, we went through various things like what is an instruction, what is an opcode, and what is an operand. All these things we have seen in the previous class. We have also seen how do you fetch an opcode and what is the example of an opcode, what is an operand, and all those things we have seen. We have went through the addressing modes. Why do we require the addressing modes? And why it is necessary. In today's class, we'll be going through the various addressing modes. Okay. Then going forward, we have also seen what do you actually mean by computer architecture. What are the main details of the architecture, like what all you require, what all it gives. You can say it gives us the instruction format, instruction set, addressing modes, and the functional modules. So I told you it is just like a design. Before you go ahead and build a building, it is just like a design, and the computer organization is its implementation. So these all things in detail we have seen in the previous class. Today, moving ahead, what we'll be doing is we'll try to define the difference between your RISC architecture processor and the CISC architecture processor. As you already know, the full form of CISC is complex instruction set computer, and the full form of RISC is, it means reduced instruction set computer, right? So as the name itself is trying to tell you, CISC computers will be trying to increase the speed, and the RISC computers will be trying to reduce the instruction set. So the goals of both of them will be is little bit different. We'll be understanding it as and when we see the differences. And you also seen that today's processors is just a mixture of both these architectures. That is, today's processors will take the best of the RISC architecture and it will take the best of the CISC architecture. It will merge them and they will be designing the today's processor. So friends, moving ahead, we'll try to check, or we'll try to look upon what are the difference, the major difference between your CISC architecture and the RISC architecture. So to come up with the first difference, CISC, as the name itself is telling you, it is having a complex instruction set. That is, the instruction set is not that easy when you compare with your RISC architecture. Now, what is instruction set? Instruction set, as we seen one of the instruction set in the previous class. What it was? It was nothing but we saw an instruction called as ADD. We saw an instruction called as ADD. What is the use of this ADD? It does the addition, right? So whatever you can see here, ADD, it is nothing but it is doing it is an instruction set which is doing the addition. So if I want to add any two operands, what we'll be doing? We'll be using ADD in a fewer instruction set. So similarly, if I want to do addition in CISC, it might be a complex thing. That is the major difference between your RISC and CISC. Okay. Now going ahead, the next very important thing we have is, what do you mean by this? Micro-programmed control. So CISC architecture has micro-programmed control, whereas RISC architecture has hardwired control. So the meaning of micro-programmed control here is all the binary variables. So I hope you already know that all our data is being done with the help of the binary variables. So all the binary variables will be getting stored in the memory with the help of your memory locations. So similarly, in your hardwired control, all your binary variables will be getting stored with the help of your hardware. So that is the major difference between your micro-programmed control and the hardwired control. In micro-programmed control, the binary variables, that is the data, will be getting stored in the processor, whereas in hardwired control, the data will be getting stored in your hardware ICs. Okay. Now coming to the goal. What is the goal of this CISC architecture and what is the goal of this RISC architecture? So the goal here in your CISC architecture is to provide a single machine instruction. That is, for every statement, it will be having a single machine instruction. Okay. So 1 second. So as we are speaking of the goal here is nothing but it is to provide a single instruction set. That is, we say that in a CISC architecture, it will be giving a single machine instruction for every statement. For each statement, like as I told, for add, it will be giving only one machine instruction. But whereas in RISC, it is not so. Here, all your operations are done using a minimum number of instructions. So that's why we say here in RISC architecture, it is having a faster execution. So friends, here in CISC architecture, we have a slower execution. Why? Because it is taking more statements, but whereas here it is having faster execution because it is having very less statements. Now going to the next thing, how the data is loaded, how the data is accepted. Here the data is accepted directly. That is, whatever the operands will be there which are stored in the memory, that the CISC architecture will take directly. We say it has direct access to operands. Okay, and what will happen here in your RISC architecture is the data will be stored, or it will be taken by the processor with the help of the registers. So this is the major difference here. In CISC, the processor will be having a direct access to operands, whereas in your RISC, the processor needs to go to the registers, and from the registers it has to pick the operands. That is the major difference between your CISC and RISC. Now the another major difference here, the memory access, that is, as we are taking directly the operands from the memory, therefore the memory access will be frequent. That is, we will be accessing the memory more frequently. But whereas here the memory access is less. Why? Because we are taking the operands through the register. That is the major difference. See friends, both the points are connected. Here, since we are taking directly from the memory, therefore there is a frequent memory access. Here, since we are taking through the registers, the memory access is not that frequent. The frequent memory access instructions are only two instructions. One is load and another one is store. So apart from these two instructions, all other instructions will be taken through with the help of the registers. Okay. So I hope these 2 points are clear. Going ahead. The next very important thing here is the instruction set. We are speaking of instruction set in this point. The instruction set here is of variable length. Like say for example, one instruction might be 8-bit, the other instruction might go to 16-bit, something like that. Okay. But yeah. So here what would happen is one instruction might be say somewhere around 8 bits, one instructions will be 8 bits, and the next instruction may go up to 16 bits, something like that. Okay. But what would happen here is in your RISC architecture, all our instructions will be of same length, fixed length. Say for example, if I design a processor of 8 bits, then all my instruction sets will be of only 8 bits, not more than 8 bits. That is the major difference, right? Going to next very important thing is your instruction cycle. Now, since again, please note here friends, again these 2 points are connected to another. These 2 points were connected to another. So this is the way you can remember the difference, right? So since we have here variable length instruction, the instruction cycle also varies. Like say for example, I have an 8-bit instruction and then I get a 16-bit instruction. Then the instruction, if I want to fetch an 8-bit instruction, the cycle will be different. That is, the number of times I need to go to memory will be different. And if I want to fetch a 16-bit instruction, then the instruction cycle will be different. So here we are trying to tell that the instruction cycle will be varying as and when the instruction length varies. I hope this is clear. But what would happen here now? Since the instruction set itself is fixed, the length of the instruction itself is fixed, that means you will be having a single cycle execution. That is, if I will be having all the instruction sets of 8 bits. So every time my cycle will be of only 8 bits. That is, the amount of time would be only of 8 bits. You can assume this like say once I will be in this architecture, that is in CISC architecture, once I will be traveling say somewhere around 8 kilometers. Once I will be traveling somewhere around say 8 kilometers, and in the next instance I will be traveling somewhere around 16 kilometers. Then the amount of fuel which is consumed when I am traveling 8 kilometers will be different from the amount of fuel which I am trying to I will be consuming when I am traveling 16 kilometers. But what would happen here? It is the same everywhere. Every time I am traveling only 8 bits. So therefore, the amount of time or the amount of execution cycle will be only what now? It is fixed. It is a single cycle execution. So I hope this is clear, right? Now, going to the next thing about your addressing modes. So when you speak of addressing modes, the addressing modes will be varying from one another. In your CISC architecture, we have n number of addressing modes. The reason behind this is because we have different length instruction sets. So if the instruction sets are of same length, then we would have had a lesser addressing modes. But what is happening here now? Both of these are different. So therefore you can see that here we have n number of addressing modes, but here we have very less when we compared with your CISC architecture. Now going to the next one, the compiler design here is specialized. It means that it is only specific for the compilation process and it would not do anything else. But when we speak of the compilation process here, it is optimized in the sense it is efficient. So the compiler here is better designed, whereas the compiler here is not that better designed and it is only specific to certain tasks. Now coming to the program size, here the program size is small. So most of our students like the programs which have lesser size, but whereas here the program size is more. So this is another major difference and one of the very interesting facts for our students. Okay, so to summarize these things, you can just observe that some things are connected, some points are connected. If you remember one point, the other point would be very similar. Like say for example, if I take these 2 points, so these 2 points are connected to one another. Similarly, if I take these 2 points are again connected to one another. So therefore you can say that few points are connected, so therefore you can easily understand. And to tell you the trade-offs, so you can see here one of the major trade-offs here is, here it is a micro programmed control, but whereas here it is a hardwired control. So it depends on the programmer whether I will be using a micro programmed control or whether I will be using a hardwired control. So most of the times it would be micro programmed. So this is an advantage. Coming to next thing, here we have direct access to operands. So I'll take this advantage of this one. So this is again a major advantage. Now another major thing here is, here I have a single cycle execution, but whereas here I have a varying cycle execution. So I would prefer a single size execution, thereby I would prefer a fixed length. So these are my advantages which I am choosing from both the architecture, and then I will combine these all advantages, and we will be designing our own processor. So this is how it would be going up. Okay. So I hope the difference is clear between the RISC architecture and CISC architecture. Very important, friends, because many of the times they ask this question in your final exam. Okay. So going forward, we'll start with our module number 2. That is the main topic of your module number 2. Even this you can consider in the module number 2 itself, that is RISC and CISC architecture. But most of the times the question is being asked in your module number 1. Now, going ahead with the next thing, that is your addressing modes. So here in the addressing modes, the major thing, what is the main use of this addressing mode? Why you should do this addressing modes? The main thing why we require addressing modes is because we need to send our data. We need to send our data from one location to another location. So this is the major work which your addressing modes do. That is transportation of the data from one location to another location. Now, as you know, when we speak of data, data has been arranged in n number of ways. To name a few, it could be a single data, like say for example, it would be just a 0, or it could be just zeros and ones, or it could be an array or a vector. So array means what? An array of zeros. Say I have n number of zeros, something like that. Say I have n number of zeros, then I have n number of ones, something like this. Okay, so even this is possible. So in this case we call it as an array of data, or it could be an vector, a simple vector. Say for example, I have a number 5, which is a vector. Okay, so this is one thing. Fine. One second. So friends, we were speaking of the various representations of data. Now moving ahead, so similarly, how we have various data, we have various addressing modes, and there are various operands for an instructions which should be referred for this addressing modes. So to name a few, or before going into further aspects of your addressing modes, we would like to address some questions regarding this addressing modes too. So the first question is, how to specify the addresses of branch target. So usually what would happen here is, I would be having a branched memory, or I would be having a branched registers. I will be having a single register, then in that single register I will be having n number of branches of registers. Even that is possible. Then how to specify the address of that branch target? The target here refers to either the registers or it could be memory locations. So that is very important aspect which we will be addressing. The next very important aspect is, say for example, I have a memory operand which is addressing directly in a single address location in the loop. So that means what we are trying to tell is, can we give the memory operand address directly in a single add instruction in the loop? So I have a memory operand, say some x or y, and can I use directly in the add instruction? Yes, it could be used, or what it is that we'll see in this question is also addressed in the upcoming classes. Next, the third very important question, use a register to hold the address of some num1, then increment by 4 on each pass through the loop. Can it be done? So what we are trying to tell here is, I will use a register. Inside this register I will hold a number called as num1, right? Then what I will do, I will try to increment the value of num1 by 4 on each pass. So whenever I execute one iteration of a loop, I want to increment it by 4. When I do the second iteration of the loop, I want to again increment it by 4. So can it be done? Yes, even that could be done, or no, using these memory addresses, that we'll see. So remember, just a small glimpse of these questions. Can we address the branch target? That we will be seeing. Can we directly use a memory operand in an add instruction? Even that could be seen. And that add instruction is inside a loop. So we have put two conditions here. First condition is, can we use a memory operand in the add instruction? The second condition is, that add instruction is inside the loop. And the third condition, or the third very important question is, can we increment a register which is holding a number by some, say 4 or 5 or whatever the wish of the user, and that should be done in the loop. That is, every iteration of the loop we need to increment the value by 4. So this is what we will be seeing in the next upcoming classes. So we will be going in much detail the addressing modes. We have some 3 to 4 addressing modes which I will be touching upon in the next class. So I hope today's class is clear. If you have any doubts, any issues, you can just WhatsApp me or call me on my number. So this is my number, and if you have any issues, you can also drop an email to this email ID. Thank you friends. We'll meet again.